What is going on, people, and welcome back to a brand new video. This video is the finale to the campervan wiring install guides, what I've been doing. So if you haven't been following that series and you are building your own campervan, you have a few questions with regards to electrical components, I've covered it all. I've made a solar panel video, an inverter video, a battery video, a battery charging video, you name it, I've covered it. And if I haven't covered your specific question, then you can just message me and I'll cover it in the next video. But what this is it's the final video just to top it all off with some top tips when doing the electrical install on your vehicle. These tips have come from my experience of 10 years as an electrical engineer, and they've also come from some of the forums what I've been reading and the most commonly asked questions and commonly asked problems that seems to be the general consensus of the DIY enthusiast wiring his own campervan. So hopefully at least one of these points helps you, if not all of them. If you do watch my videos and you have been liking them, I really appreciate a like, a comment, a share, subscribe. I didn't realise how important that sort of stuff were to influencers until recently, so if you want to repay me for helping you out, then that is the way you can do it. So going straight into it then, the first one is exposed conductors. So as you're doing your van, whether you're doing the DC side or the AC side, one of the biggest DIY faults that I seem to see is exposed conductors. And what I mean by that is when you strip the insulation off your cable, only strip it enough to go into whatever you're terminating it into. So if you're putting it into a connector block, make sure that all of the exposed copper goes into the connector block and then you tighten it so you cannot see that exposed conductor. The same works for terminating into your fridge. Every time you terminate a cable, you don't want to see any copper. I appreciate that might be difficult for the DC side of things where you're using your ground as your negative, but you can still try and do that as neatly as possible with things like ring crimps, heat shrink, and just tidying up that area. The more time you take on your installation to start with, the better and easier it's going to be to fault find in the future. The next tip, and we've all fallen foul of this, and I still do it to this day, and I'm sure everyone else does it, cutting cables too short. Certainly when you're on a budget, you want to try and make the most of the cable what you've got. But one thing I will say is it's always better to overestimate than underestimate. If you pull a length of cable out and you know you need to go from the front of your vehicle to the back of your vehicle, I'd always add a couple of feet on either side just to make sure that you're not going to come up short once you've routed that through the ducts and through the area what you plan on routing it through. That is a common one, and it just means you're going to waste that length of cable. You might be able to reuse it later on in your build, but better to get it right first time. So always overestimate your cable length. And I appreciate that can get expensive when you're doing your battery install and you're using thick cable for your battery install. However, better to overorder than not have enough. Another top thing I see from the DIY enthusiast is making it unmaintainable in the future. So we've all got the good ideas, we've got our wiring diagram, we've got everything that we covered in the previous videos, and then when you're actually getting to the job, it's really nice to try and make things nice, neat, tidy and away where you can't see them. Of course we don't want to see the electrical installation, we just want it to function. That being said, there's a very fine line between doing a functional electrical installation and having it unmaintainable, to the point where if you did get a fault, it would be impossible to trace your cables, or it would be impossible to get to that fuse what you've installed because now you've installed a seat over the top of it. Trust me, you'll be pulling your hair out if you ever get around to fault finding on that. Hopefully you don't need to. Hopefully you've done it right the first time and it lasts the length of your lifetime. However, always preempt that and try not to make things unmaintainable for yourself. Earthing a camper. This is a controversial one. And yes, I'm saying that, an electrician for 10 years, I work on plenty of DC and AC installations, I work on generators, large generators, small generators, you name it. And once you've done this build and once you've added an inverter to your build, in essence you've got a generator. So we'll go into that and I'll explain why my thought process is that you probably shouldn't be needing to earth your camper. And what I mean by that is earthing your consumer unit to your vehicle chassis. Right then, so as you can see from this image, it's quite rudimentary. Basically what we've got here, we've got an appliance which is simulated by a toaster. It's then going to your 13 amp socket, which then goes to your consumer unit, which then goes back to your inverter. I've set it up like this because this is how I've got mine set up, and I assume this is how most people set theirs up. And then when I go to shore power, my shore power connects to my inverter, and then my inverter decides to convert to shore power, rather than having it straight into the back and having a physical change lever. But if you did have a physical change lever, it would probably be a very similar setup to this. And of course this is not a wiring diagram, so don't use this to wire your vehicle. It's very rudimentary. I've obviously missed lots of components off this, there's no batteries there, etc. This is just to illustrate my point of earthing to the chassis. The black cable between the appliances and the socket and the consumer unit, that simulates the earth cable. we're chatting about an earth fault in the event of an RCD failure. Because normally, if you did get a ground to earth, your RCD would trip. But of course, we're talking about this if it were to fail, because if it were to always operate, it wouldn't be an issue at all. So now, if like me, you didn't earth it and the appliance were to fault, this is what would happen. The appliance would go live, so the metal components on the appliance would then be live. The metal components on the 13 amp socket would be live. The metal components on the consumer unit would be live. Each leg going out of that, the earth would then go live, and then each socket on that leg would be live as well, and the components, the appliance, they'd all go live. And then by the time it got back to your inverter, it would be converting it back into DC, so you'd like to think there would be an earth separation in that, so that everything on the flip side of that would be 12 volt DC, and none of your earths to your vehicle would then go live. So then here is a picture of what would happen if you were to put an earth from your consumer unit to your vehicle. You see this quite a lot, and it's not bad practice. In fact, it's good practice, but only in one circumstance. So if you would put your earth to your consumer unit, the red bits are what would then go live. So now you can see everything's gone live, what's gone live before, but now the vehicle chassis is live as well. Now this has presented two problems. The vehicle chassis is live, and you could be the person that would ground it, thus get an electrocution. Secondly, the components in your vehicle are probably not going to be 240 volts. They're probably going to be either 24 volts or 12 volts. Now you're putting a 240 volt through your 12 volt component, which, to anyone that's ever troubleshooted vehicle faults, this is bad. We could blow sensors, we could blow modules, relays, all sorts of problems by overvolting components that are rated for a lesser voltage. Now, I say that this is not right for the simple fact that this would be the correct way to do it if every time you use your install, you use an earth spike. So that the golden solution to it would be to earth your consumer unit to your vehicle and then put an earth spike into the ground and strap that earth spike to your vehicle. That would be the golden solution. But people don't use earth spikes. I want to use things on the fly. So for me, the risk of having an earth fault and my RCD failing is one, unlikely. But if it were to be likely, I would like to isolate that earth fault to the appliances that are in that faulting loop. If I were to strap it to the chassis, everything metal in that vehicle is now live. So that is my thought process on this. I've spoken to sellers of equipment for DC and AC installs into vehicles. They have the same opinion of me on it, and I know it is very divided throughout the community, but hopefully I've given a bit of context to my opinion rather than just saying this is how you do it and you should believe me. If you want to be super safe and strap your consumer unit down to ground in your vehicle, then sure, do that. But make sure you use an earth spike. And for anyone that's looking at that thinking, well, what about when I'm at the electric hookup point at the campsite? Then yeah, again, you could strap it to your chassis. It would be fine. You should be earth sparking your vehicle, but then you've got another thing to think about is that the incoming from the electric hookup has got an integral earth in it. So any fault that goes through that consumer unit will be going down your incoming back to ground. Because if the electric hookup point has been tested and inspected as it should have been done, it's got an earthing point in there. So hopefully that's cleared some stuff up for you. It's given you a bit more information to decide which path to take on this massively controversial topic of earthing consumer units to campervans. The next one is future proofing. Of course, we all know what we want now. We've done our diagram, we've worked out our needs, but we don't know what we're going to want in the future. And what I will say is when you've got your units out and when you've got your seat out and you've got a nice, easy working environment, maybe put an extra few cables in there. You can always leave them coiled up. You don't have to put the fuse in your fuse box. You can identify it as a leg and identify where it goes. So in future, if you were to add something in that area, it's easy to do. The cable's already there. You'll never see it until you need it. And also what that does mean as well is if you do have a fault in the future, let's say a cable breaks and it is in an unmaintainable area, you can just use that additional leg and remove the faulty leg from your system. So making it future proof is a big one for me. It saves us the work in the long run, and no one wants to be tearing the units out once they've finished the camper. No one wants to be doing that at all. Follow existing cable routing. Now, I appreciate this is not always possible. However, if in your van there is a big long ducting going down the right hand side of the van with all the cables going to the rear of the van, and you can put your cables up there with that, then do that. There's probably a good reason why the manufacturer put it there, for one, and for two, you can keep everything together. So then again, when you're fault finding, you know where everything is. You can always isolate yours in a separate bit of conduit, just so you know what is existing and what is aftermarket, but I will for sure try, where possible, to follow the existing cable routing. Minimum amount of joints as possible. Now the reason I put this one in is because prior to watching this video, I've done quite a lot of research on other YouTubers' videos, on forums, questions asked, and one of the things what came up on quite a popular YouTuber's video, and I'm not going to name, but if you're probably looking at these videos, you'll probably come across them, and they were advising to cut your cables shorter to make it easier feeding it through difficult areas, and then you can just recrimp an extension onto the cable. Now this is bad practice. Good practice is to have as minimum amount of joints as you possibly can. If you can have one length of cable going from your supply to your appliance, that's perfect. You have one joint going into your supply box and one joint going into your appliance. Simple as that. Whether they be like through crimps or whether they be spade connectors, it's just bad practice to have that connection there. Where possible, keep that cable as integral as it comes off that reel. I appreciate it's not always going to be possible, and we'll cover off on that later on in the video on tips to do when you're making joints. Expense items, and what I mean by that is stuff that you're going to put into your van that you're not going to get back at the end. Of course, we want to buy the right tools, we want to do the right job. However, the expense items is where people will often scrimp on. When you see horror stories of camper builds where the electrical install has gone terribly wrong, it's usually because the person installing it has scrimped out on a 12p grommet. Now, get yourself a box of grommets. You can get these from anywhere. Amazon's probably your best bet. Get yourself a box of varied size grommets, so every time you're going through some metal work, you can put a grommet in there. What I will say though is try and use mechanical protection where possible. Now I appreciate that the existing install of your van, so the existing wiring in your van, is usually single core, single insulated, running the length of the van. By the 18th edition standards, this is probably bad practice. Realistically, we want double insulated at least. So what I will say is, where possible, try and get a bit of mechanical protection there. So if you're going through a vulnerable area, for example, through a side step, I'd try and put a bit of flexible conduit around that, or even solid conduit if you can make it work. Just that vulnerable area, because you only have single core, single insulated cable going through there, and it's easy to break that insulation should it be on a wear point or on a locating dowel of that step. Of course, it's not always going to be practical to run conduit right around the van, and I would never have it on display, but that is the trade-off for me. I know I'm taking that risk by not having it on display. But if you can put that conduit in and it's not on display and it's doing that job as secondary mechanical protection, then definitely do that. And finally, for our last point, is IP protect stuff. IP stands for ingress protection. You've got varied stages of ingress protection. And just alluding back to our joints, what we did earlier, we were talking about joints and stuff like that. If you are going to put a joint on there, I would massively recommend getting an IP rated joint. Whether that be a very basic IP rated or a full-on waterproof IP rating. I'm going to pop the IP ratings up on the screen now so you can gauge what you need. But for example, I have a joint around my sink area. I've made sure that joint is a full watertight joint. It's not that expensive to buy them in ones. You can buy a small box of them and it's just going to become useful when you're wiring your van. Definitely don't start using spade connectors under your sink. That is just a terrible idea, and it is a sure way to have problems in the future. I know I've just rattled through a lot of points there, but I'm quite keen not to take up too much of your time, because I appreciate if you're watching this, you're ready to get going and wiring your vehicle. If you have any specific questions on specific parts of your installation, like I said at the beginning of the video, I've got a video on each topic. So go to that video, watch it. If you don't get your answer, comment on the video, I will answer it for you. And again, if you have enjoyed it, give me a like, give me a subscribe. I will catch you in the next video.